Okay, good morning, everyone. I see people are joining in. So just wait another minute for us to start. And okay, so 9:30, I think we can start with our event. Thank you very much for joining us today. So my name is Renata Barros. I work at the Geological Survey of Belgium, and I am the coordinator of the GeoConnect³ project that is organizing this webinar series for you. And I will be your host today during our final event, Subsurface Interactions. And this topic that one way or the other overarches everything that we discussed earlier this week, and many, many other topics in the geosciences as well. So this is what's on the menu for today. We have two great talks to look forward to before a Q&A and an interactive session. But for now, I would like to introduce our group today. So let me just stop sharing quickly. So our first speaker will be Isaline Graveau. She's an engineer at the BRGM, French Geological Survey, and the leader of the work package dedicated to subsurface planning and management of GeoConnect³d. Hello, Isaline. Good morning.
Good morning. Good morning, everybody.
And our second speaker, Chris Peasons, is a geologist and subsurface management expert at the Geological Survey of Belgium. Hi, Chris.
Thank you, Renata, and good morning.
And our moderator, Andrei Bocin-Dumitriu from the Geological Survey of the Netherlands. Good morning, Andrei.
Good morning, Renata. Good morning.
So today, as you see, is a GeoConnect³ event. We don't have an external guest speaker, but we would like to bring it back to our project's objectives and show you a little bit of this today. But before explaining how the day will go, or the morning will go, and starting off with the presentations, I want once again to give a bit of background on GeoConnect³ for the ones that are seeing it for the first time. My apologies for the ones that are watching again. There will be some repetition, but also focusing today on the relevance of subsurface management and interactions in our project. So let me just share my screen once again. Okay. So GeoConnect³ is part of the GeoEra research program, funded through a Horizon 2020 Research and Innovation Grant. And you that are watching us today, you're probably well aware that our society is strongly dependent on resources coming from the ground below our feet, or the subsurface, as we like to call it. And GeoEra has the main objective to contribute to the optimal use and management of the European subsurface. So these uses of the subsurface, they're covered by three research themes: geoenergy, groundwater, and raw materials. And a fourth theme, the information platform, is the common objective of all of us to make the data online, available online for free. And GeoConnect³ is part of the geoenergy theme, along with other projects covering different aspects of geoenergy resources. But our project, as the name suggests, is a point of connection between all these different projects, and also with others in the groundwater and raw materials themes as well. And we want to provide a robust model that can accommodate all types of geological information. And I will explain about this a bit later on. But this scheme is a nice summary of how GeoEra as a whole is doing science for society, by starting from geomodels and data of different themes, going through the assessment of this information, and then reaching the goal to provide support for decisions about the subsurface, making all information available in the free online platform. But why is this important? So the use of resources coming from the subsurface will increase more and more over the next decades if we want to achieve ambitious climate neutrality goals here in Europe. And sourcing affordable energy, increasing sustainability, access to clean water, climate action. A lot of these goals, they rely on different uses of the subsurface. And the subsurface is ruled by geology. And this means that geological information will become more and more crucial for good decision making. However, science and policy are not as close together as they should be. We see that on one side, geological information is not necessarily accessible and understandable. And on the other side, scientific information is not being used to its full potential for decision making. And we want to help close that gap. And to do this, our project involves 20 partners from 16 countries. And we have 2 cross-border case areas. Route to Rhine and Pannonian Basin. And 2 one-country pilots in Ireland and Germany. And the events this week had a focus on the Route to Rhine area, but you can expect a similar event for the Pannonian Basin in a few months. But anyway, we share a single goal to develop and test this new methodology to prepare geological information related to the subsurface in a more understandable way and make them easily available for stakeholders in GeoEra's online platform. And we hope this will help to bridge the gap between science and policy, especially in subsurface management. But so what is this methodology that I keep mentioning? So GeoConnect³ is rethinking the way to present geological information. And we're doing this by using the information available in conventional geological maps, 3D models, and so on. But digesting this information to make it more intuitive by looking at the different geological features in terms of their boundaries, or what we call limits. And we're also incorporating information that is usually overlooked because they are, treated as small anomalies, but that they point to specific geologic manifestations of processes happening in the subsurface. So the combination of these different types of information, results in our structural framework model with annotated geomanifestation data. And like this, our aim is to improve geological understanding of any area. So our project started in June 2018 and will end in June next year. And part of the testing of the first version of our methodology is to get the feedback from potential end users. So you that are watching us today. And as I mentioned, another event will be organized by the Pannonian Basin area in a few months. And we will have a final joint event for stakeholders early next year. So for today, we have 2 presentations from scientists working in our project to open the discussion about subsurface management. And we will do this after their presentations. So we have these 2 presentations and we will open the discussion through a Q&A session and end with an interactive session, once again, using polls to get your feedback. So you know the drill. During the presentations, please write your questions using the Q&A button located at the bottom of your screen. And you see that you can upvote existing questions with a little thumbs up so that we know that many people have the same questions. And to get you ready for our interactive session later, I want to make a test right now. We'll use the poll everywhere. It's super simple. You go to pollev.com/GGeoEra900. The link should be there in the chat for you. So you register with your name and you get ready to answer our test questions. I will leave this for a few seconds before opening the first question. And if you've seen any of the previous sessions, I know the questions will be the same, but I encourage you to participate. And today we have an extra test question as well. So I'm going to go ahead and open the first one. So what is your background? And if you have a background in geoscience, please specify the area. If it's geochemistry, hydrogeology, or something like that. So we're starting off. Geophysics, geology, public policy, structural geology. Okay, we see some results coming in. That's nice. Geoenergy, environmental geology. It's nice that each of the days we had, although geoscientists in its majority, we had a nice spread of the areas and the backgrounds. So that's very nice. Thank you very much for your answers. That seems to be working well. So I am going to go to the second one. Where are you based? Please click on the map. And if you're based outside Europe, you have a little map on the top right. So we're seeing some results there. Some nice spread across Europe. No one from outside of Europe today. Let's see. Okay, I think that's it. So we're going to go to our third question, which is to warm up to the discussions coming in the presentations. So I know well the geology of the subsurface below my city up to a depth of. So we have 0 if you have no idea. And we have something up to 5,000 meters. So let's see. So we seem to have quite a few people that know well the subsurface geology. Okay, changing. Okay, that's very nice. I think the test works well, so you should be ready to go for our interactive session later on. Thank you for your answers. So we are ready to start off with our presentations of today. And we're going to start with Isaline Cavo. And she will start by telling us about multiple uses of deep subsurface foreseeable interactions. So let me stop sharing my screen. Isaline, whenever you're ready, you can share a presentation with us and start.
Okay, I start. Is it okay like this? So,
yes, perfect.
Good morning, everyone. So thank you, Renata, for the introduction. I'm Isaline Cavo from BRGM, the French Geological Survey. And I will say a few words about multiple uses of the deep subsurface and foreseeable interactions, because it's something that we in GeoConnect project, we are looking at. It's one of our objectives of the project. So it's something we are especially dealing with in the work package 5 of GeoConnect³ project. And things I will be presenting you are come from the work we are currently doing in this project. So as many of you know, as you are implied in geosciences, the subsurface has a paramount importance for human life on Earth. The subsurface is paramount, and there are large variety of uses that are done of the subsurface, the space underground. and as well in the past or at present time, but also in the future, especially for energy transition, there will still be an important use of the space underground. We can divide these uses of subsurface into extractive uses and storage uses. Extractive uses are all the uses that exploit resource from the underground. So typically all the mining activities such as coal or ore mining, and of course oil and gas exploitation, but also water abstraction or geothermal activities. These two uses have the particularity to be refillable uses, and so on. It's not an extended list of uses. And the other uses that we can do of the subsurface is the exploitation of the underground space or particular condition in the underground, such as pressure, temperature, isolation from the surface. So typically these are waste disposal underground, also underground natural gas storage, which it is an operation use of the subsurface. In many countries around the world, natural gas is stored underground because the underground offers large capacity for large volume of gas. And this way we can store natural gas during the summer when the demand is less, and produce this gas for the high peak demand in the winter. This storage are mainly in salt cavern, and also in aquifers. These are two types of storage. So in salt cavern, where a cavity is created by leaching in a salt formation, and in aquifers, the gas is injected into a porous rock and a reservoir. Storage uses are also looking at for the future. There are many new uses that can be done of the subsurface, such as CO2 storage. That is operational use, but not so developed in the world. And KS, which is also storage of compressed air in the underground. And these two are rather prospective uses and can be deployed for in the context of the energy transition. This leads us to the issue of subsurface management, because we can see that there have been, during the last decade, an increased use of the subsurface, and this increased use of the subsurface will continue in the future, as I said, in order to provide us with solution from for energy storage or CO2 storage, in order to achieve the ambitious goals we have fixed for at the Paris agreements for gas CO2 emission reduction. And we see that if we continue on using the subsurface in an increased way, there may be interaction between the different applications. And also we can foresee competition for the same geological settings. So this picture, it comes from a publication by Bauer and Al, and it depicts the issue of the increasing use of subsurface with different types of uses, such as water abstraction, heat storage, that's another prospective use of subsurface, compressed air storage, energy, natural gas and hydrogen storage, and of course geothermal. So this interaction can lead to what we call conflict of uses. This is an interaction between two uses which are negative interactions. That means that one application prevents the settlement of the other or its economic running. And the conflict of use does not necessarily concern simultaneous operations, but the setting of a particular subsurface use can prevent future utilization of the area for other subsurface uses. So these are a direct conflict of uses when two subsurface uses target the same underground volume. So for different applications, so there is a conflict at the planning and permitting stage because there are a choice to be made between the two possible uses. But we can also have indirect conflict of use when the influence radius of subsurface activity reaches the influence area of another subsurface activity, which is in the vicinity of the other. It's particularly true in a pore space application when there is a pressure impact that can reach some further distance than the area required for the application, and can reach another subsurface activity. And this conflicts also may have the particularity to be not to be reciprocal, but maybe unidirectional when one of the application is more sensitive to being influenced. So I will show you some examples for explaining the conflict of uses. Many of my examples will come from the French case study, of course, because it's geology I better know, but it's only example, and this can be applied in any other part of the world. So this is the case of deep saline aquifers. This map shows the geothermal potential in France, and we can see that in France we have two main sedimentary basins, so the Paris Basin and the Aquitaine Basin. And this two basins contains deep saline aquifers, and these are the main potential for these aquifers have potential for deep geothermal activities because we can find continuous aquifer with temperature above 70 degrees. So in these two basins, but it is also the same formation that we also have potential for CO2 storage. So there is a kind of competition. There can be a kind of competition between geothermal and CO2 storage, since both type of subsurface uses that target the same geological formations. So this is direct conflict at permitting and planning stage. We may have a planning to a reflection to lead in order to decide what kind of subsurface use we want to develop in priority or in which area. The next case study is also in southeast of France. The case of the storage gas in Lussigny and Isotte. This is a natural gas storage operated by Terega, a French company, which is located in the Aquitaine sedimentary basin, so southwest of France, in this part of France. There are two reservoirs at this storage site, the Le Sanier and the Izote reservoirs that are in the inframolastic sands aquifer that are Eocene sands aquifers. The first one is 500 meters deep, and the second one Izote is the more recent and deeper. It's 900 meter depth. The other burden of the storage are Aquitaine molas, so it's a plastic, clay, and carbonate beds up to 500 meters thick, so very good overburden. And this Eocene sands aquifer, so I show you here the cross-cutting. The sands, inframolastic sands are here. But this aquifer is also used for a large variety of economic sectors, such as potable water, thermal water, industrial water catchments, geothermal activities, irrigations, and so on. So we are in the case of multiple uses of the same aquifer. The fact is that the gas storage operation generate seasonal variation in pressure variations in the aquifer, as pressure increases when the gas is stored and pressure decreases when the gas is produced. So here is the variation of the volume injected in both reservoirs with the year, so we can see a seasonal variation. And there is a pressure impact that is observed in several wells, tens of kilometers away. So these are the two storage sites, and you can see the red and the different dots are the observation wells in the area. And we can see in the pink dots that some of the wells are pressure impacted. So there is, for example, in the Barbotan area, that is detailed here, so it's this area. We can see a pressure variation of the piezometric levels that are correlated with the natural gas injection variations. So this pressure impact is observed in area around the storage. And also there are thermal stations around 20 kilometers away from the storage sites, which have spring rate decrease, but no chemical impact, just pressure impact. And also water exploitation for drinking and irrigation in the area also present some pressure impact. So all this are no major consequences. Only pumping installation can solve the issue, but we can see that there are some connections between the different uses of this aquifer. The second case study is in Belgium, in the Lonhout. I'm sorry, I don't know how you pronounce it. And it is a limestone aquifer in the dimension for the age, which is overlain by mudstone. There is a gas storage reservoir in this aquifer located in a dome structure. So you can see in the cross-cutting here or in the 3D model, the dome structure where the gas is stored. This reservoir has good storage properties due to gasification. But also in this case, pressure waves from seasonal injection and production could be observed in the aquifer. Particularly, there are also the same aquifer, but outside of the dome structure, some deep geothermal projects that are started. And so we can foresee that mutual interferences might occur. In this particular case, for the same aquifer, there are two adjacent license areas, so for gas storage and for deep thermal exploration, that fall under different competencies. So the gas storage falls under federal law and has been active since 1985. And the deep geothermal project falls under the Flemish competence and will start soon. So we can see with this case study that there are a regulatory issue for subsurface management, and this raises a need for regulation of subsurface as a whole. The interaction between the uses of subsurface can also be positive interactions. For the moment, I only spoke about conflict of uses, but we can also have reuse or synergies between subsurface uses, which can be complementary to each other. So the reuse is the most operational and current positive interaction we can have. So the later activity uses the effects of a former one. So typically it's a case of salt caverns that are left after salt production, or depleted hydrocarbon reservoirs. So both salt caverns and depleted hydro reservoir can be used for storage purpose. These cavities or reservoir have proven their storage capacity and can be reused for other fluids. Also, many cases of uses of old mine shaft for other reuses, such as pumped hydropower installation, for example, but it's only an example. But also we can have synergies. That means that two projects in underground space are simultaneously complementary. I can give the example of waste acid gases that are reinjected into a hydrocarbon trap to sustain the exploitation pressure, but also recovering the heat energy from produced water, and so on. This is an example in south of France, in Gardanne, of synergy in the reuse mode. In south of France, we have an abandoned mine, Gardanne, and there is a project there of exploiting the mine water's potential for heating and cooling of an eco-district that is start being built. So in this case, the well, one of the main wells of the abandoned mine, which is more than 1,000 meters deep and 10 meters large, so a huge well that is now filled with water. So this water is used for heating or cooling, depending on the season. And there are also projects of heat storage in these mine waters that are under consideration. So all these interactions lead me to emphasize the need of subsurface management, because we can foresee that we need to optimize the use of subsurface in order to avoid the conflict of uses, and at the same time look for potential synergies. The subsurface management is an issue that already raised and is already well identified in urban and shallow context. So the urban subsurface is intensively exploited in big cities mainly. And we already have a lot of studies that are leaning on this subsurface space optimization and management and planning issue. But there is a rising issue of the same subsurface management question in deep and subsurface context, as I showed you previously. And with this subsurface management, I want to emphasize the importance of temporality, because as I showed, that many synergies are a result of reuse of former uses of the subsurface, such as abandoned cavities, for example. But we also have to tackle the long-term aspect of the subsurface use for its management, and address future uses for the subsurface as well as the current and the past ones. So this is a question that what we plan for the future, and discuss if we, for example, should reserve some areas for specific applications in the future. A word about the regulatory framework in Europe, because the GeoEra projects, and especially GeoConnect³ is focused on Europe and pan-European issue. So we can see at national level in the different European countries that there is a large diversity of authorities and competence inside one country. That is, so it's already difficult sometimes to have a regularity framework at national level, but also between the different countries there are a lot of differences in organization, so we cannot provide a single pattern of managing the underground space. And to our knowledge, none of the countries has incorporated the subsurface management issue in a legal framework, such as what is done with land space planning. And we can also have the case of inconsistency in regulations that create lack or overlapping of competencies. At European level, the regulations related to subsurface uses are dispersed in various directives or decisions. So there is a need at European level for regulation of subsurface as a whole, and not only for urban areas, but also for deeper subsurface. And for this part of my presentation, I thank the PGI team involved in GeoConnect³ project and Monika Koniszynska for these elements, because they carried out a fantastic work done on this part of the project. And and they are preparing a report on state of the art of subsurface planning and management that will be issued in the next weeks. So if you want to have more information about this, you can look for this report. And so what I presented here, it's really ongoing work in the GeoConnect³ project, and we are still working on it, and want to our objective is to achieve some generic conclusions and recommendations at pan-European level. And our objective in our methodology in GeoConnect³ project is to draw generic lessons from the case studies about subsurface management, of course. And these case studies are rock-to-Rhine and Panionian Basin. So today we are rather focused on rock-to-Rhine area. And so we still need feedbacks from stakeholders of the subsurface management to raise the issues that are faced in this area to help us with our developments in the project. So it's also one of the objectives of this of today's presentation is to raise remarks and feedbacks on this subject. And I thank you. That's it for my presentation. I thank you for your attention.
Thank you very much, Saline. Thank you for this nice overview. And please don't forget to write your questions on this in our Q&A that is going to happen right after our next presentation. Yes, or comments, that's true. So now we are going to move forward with the next presentation. Chris Pieces from the Geological Survey of Belgium. He will talk about discussing the invisible from generic to custom tailored understanding. Chris, whenever you're ready.
I'm ready. I was just looking for the mute button that had suddenly moved on my screen. Yes, so hello everyone. This is really the, for us, the most important presentation of the four that we've had in a row, not because we don't like the other project, but because this really determines what we're going to do with the project in the last stretch. You could look at it as the first 2 years we've been playing around like children, and during this week we're going through puberty, and from Monday onwards we're going to behave like adults, and you will determine our character for that last stretch of the project. It's been said several times, but I always like to emphasize, and I really like the first question that we had, where you saw that we actually are talking to two different groups in our audience today. Those that live like normal people at the surface, and everything looks there and behaves there like that. And yes, they know there is some connection to the underground, but that's a little bit vague. And then you've got another group for which the surface is really a detail, and they spend their lives, at least in mindset, in the subsurface, and are aware of the great potential there, and also of the different complexities that you have to take into account. How to bring these things together, or how to communicate between those, and that's certainly one of the goals that we would like to go through. And this is a little bit of the recipe that we think we want to develop in order to make all of this happen. And just go through the different steps that we will also be following in this presentation. First, we will going to start by thinking in a generic way, something that Saline also pointed out in her nice presentation. Points 2 and 3, we're going to skip them. They're just more technical exercises for the geologists behind them. But it's basically translating that. I will quickly show how this goes, but not in a great amount of detail. Then going back again to the experience, to the sharing of information, working at the 3D level, how that we've given that elements that actually work as a speed course in geology, where you can tell a lot about geology in a very intuitive way. And thirdly, point number 5, how we link and can embed results from other very ad hoc studies to our structural framework. And it can be 2D models, but especially 3D models will work there as well. And then in the end, we're going to come back a little bit to the real words we're going to use as well, or we want to use in the project. This is, when talking about generic schemes, this is the most generic one. It's the one from Bauer et al. That Saline also showed. And this is obviously a very generic, a very good one, but extremely generic. I mean, it gives the impression of having geology there, but it is not as concrete as you want it to be as a geologist. But it is certainly a very good step to just think about all possible relations in there. But you've got other, we can grade a little bit through these types of generic schemes. And this is one that very freshly has been developed by one of the other GeoEra projects, Fogueira. And as you will see, we try, we don't steal, we don't borrow, we share within GeoEra a lot of results. And that's one of the big strengths that GeoEra is. It's really a consortium of 15 different projects. Like this one very much, although it was developed specifically for groundwater, it is one that we can use in different ways. And actually, if you start looking at this scheme here, I'll quickly point out these are carbonates. This is some sediment infill, and this, well, They call it an intrusion. It could also just be a crystalline rock. If you look at these three big elements, this could actually be a model more or less for the Ruhr-to-Rhine area. Ruhr-to-Rhine mainly would sit into this kind of situation. And there we're going to actually, in that position, we're going to discuss two different models. Just gonna show them here for visual reference. So you can see where they pop up later. This part is, well, this setting is what you find in the Ardennes. And there actually you see there's limestones with karstification on top. These are things that we've seen before. These are pictures from the geotourism or the session that we had on Monday, where you can actually see how these are water can be an actual resource in these kind of areas. And you can also, here you saw that in the Ardennes are actually folded. So it's not, this may give a very horizontal presentation, but you can also observe these things as being folded and deformed and everything, making everything a little bit more complex. And if you go to the more crystalline or massive inliers, there we've seen only in the geothermal session how in Belgium at least one of those is really a hotspot for deep fluids welling up to the surface. And these look like very dirty fluids, but actually they're very tasty. They are the basis of the spa water that is being bottled there. But now drawing this into the project, when we have such a scheme, it looks like a very nice generic scheme. But for those that have been following the previous sessions, they will wonder how do you link such a scheme to the structural frameworks? And that's actually very, very easy. If you see it on the right, we've got here different, just 6 different contexts that we work with. Well, to be honest, we may add a seventh one, but certainly a very limited one. And here we just color these limits. And you see 3 colors being used. These are the top 3 that we actually are using, and these are contacts between rocks of different composition. Unconformity, which is a bit of special type of contact, but it's very important to define certain units, and faults in red, obviously. The other 3, we will not see them on this setting because there you really have to zoom out. These are the big scale tectonic boundaries that you will be looking at. But just drawing even this generic scheme as this here is basically already putting it inside of a structural framework. And if you haven't yet heard about the structural framework or the introduction wasn't clear enough, I'm not going to explain it in the technical parts of it, but in the next slides, you will certainly understand how this will more about it and try to learn how we work with this. And then we move from the generic scheme, and that's really currently a very big gap that we want to bridge to something like this, a geological map of Europe. And here, even for geologists, you will consider this to be an overload of information just in one screenshot. It's because I put geological map of Europe on top of it, or you know it from the past, that you will actually be able to recognize parts in it, at least in the first 30 seconds of looking at this screen. And let's compare this geological map of Europe, which is, by the way, a very good one, is the IGMI 5000, to how we present information at this level. This is the maximum amount of information we will throw at this level here. It looks like too much to comprehend, but I will show you that you can actually walk through this in, let's say, 30 seconds and actually understand what's all here. There is obviously much more information that you need and that you need to work with, but we will bring that additional information into the system only when you start zooming in. So that's something, and then it gets the Google Earth kind or Google Maps kind of feeling, where you just are being fed information at the level and at the rate that you actually need it. Let's have a look first at Europe, but a very quick one, because we've done this certainly before as well. You will see that we systematically always define limits first, and then we do units, and we keep adding this until we actually have enough to define the different building blocks of Europe. And here you see, although there are a lot of lines, there are only 3 colors of lines. The limits between plates, current or old ones, the green one showing the limit between ocean and continental blocks, and red ones for big faults, and some of them we need as well here, not all of them. And these are enough, and then suddenly the picture becomes much clearer to define the actual building blocks of Europe. And it's important here to realize, I think even for geologists, is something that I think is not sufficiently emphasized, that if you look at geology, there are two levels to look at. At this scale, certainly this is for me the best summary of geology of Europe, because this shows all the different elements that have accreted onto Europe through time. And until that point of accretion, until it merged into the big Eurasian plate that it currently is, these all had their very separate and different histories. They were merged, that gave rise to origins, and once these origins were formed, then this whole thing much more started behaving like one block, and you get structures that basically cross all of these different building blocks, and you get a new episode in geology, where the building blocks themselves are less important, but what we call basins, and these are mainly graben basins, which are shown here, start to become the dominant units to talk about and to understand geology in. We're not going to talk about the grabens, we're going to talk about the Pannonian Basin, which is circled here in red, for a very specific reason, which will immediately become evident, because even at this level, we're going to zoom in just a little bit, not too much, to know where we are, but without even having to reveal more information. But you see, some Pannonian Basin is it's very big unit. It's Hungary and then some. It's got different macrotectonic plates around it. But what I want to show you is that it's also one of the very few locations in Europe where you can actually have a 3D put a 3D model that is not just 5 or 10 kilometers deep, but actually several hundred kilometers deep. And what we're doing now, and I will highlight a few structures so you can actually see them or relate to them, is you've got, this is the way we think we can switch from 2D, which is very useful, to 3D, and that's what we're going to need if we want to discuss the subsurface. And you do that by keeping 2D on top, and then highlight the structures that you also have in the separate model. And these, in this case, these are really the bigger, they are not really faults. Well, yes, they are faults, but at this level, they're a bit behaving more like plate tectonic boundaries or suture zones. And this is something we're going to do 2 or 3 times to show you how it also works at smaller scales. But this is just one where you can actually do it already at the more or less the pan-continental, pan-European scale or the crustal scale. You do not have to switch to 3D here. You can also do it for 2D, but it's nicer, I think, to show how we do it for 3D, or hope to do it. Let's now switch from Pannonian Basin, which was very interesting and which is going to get its own set of presentations to the area that we're working in. And what you saw here, this blue line was also present as something that crosses right across Europe. This is actually the Variscan deformation front. I was mentioning that the origins of Europe, but not in a great amount of detail, but it suffices to know that everything south of this has been deformed by the Variscan orogeny, while the north of it has been spared of this. And therefore, this one is a little bit less complex, no folds there. I mean, no folding there, while the south has been much more tectonically influenced. And this very big European structure also runs right across Belgium, and that's why Belgium has this fantastic and marvelous geology to explore. For the rest, this is really the geology of Belgium as summarized as you can possibly present it. So we have this big divider here. You've got some even older units, which you could say, well, they're something like crystalline inliers or very massive blocks. And then everything in yellow are basically the different basins that you can find here, and basins are by default quite interesting if you start talking about subsurface management, because they hold the reservoirs that we are interested in many of these elements. Okay, in order to really put in the 3D level here, we actually have to zoom in a little bit more, a little bit further, and then you will see that the blue front actually splits up into an array of splay of different actual red faults. And here in the blue outliner is the model that we're going to visualize in the next view. And here you see again the 2D view on top, and here below is not yet the model, but basically the input there. We are looking actually at the collieries beneath Liège, beneath the town of Liège. These existed several decades ago, and then the whole geology was still put down on paper, in this case on a whole set of very elaborate profiles. These were brought in into a big GIS or geological modeling software in order to not to reconstruct the actual coal mines or the coal seams, but the dimension reservoir, which is deeper than that, because we have very little information on that in this area, but we have very detailed information of the little bit shallower levels, so we try to extrapolate from that below. When I say we here, I mean the survey. This is already data that we're now importing from other ongoing projects into, and we want to show how easy it is, or how straightforward it is to actually link in these copy information from other projects into this. It's actually a project running in parallel, and we're not directly involved in it as researchers, but we are close enough to get access to very early copies of this information. And this is what we're going to show here. This is actually the top of the reservoir, the top of, again, the carbonates that form, for example, very good geothermal reservoirs here. Here at the depth, just for reference, let's say 1500 to 2000 meters. This is the top. It looks a little bit strange in itself, and you don't have much to go on, but there are some very important faults going through that, and these obviously at depth they are a little bit more different. They also have their own dips and orientations, but these ones we know them from the surface maps, and so these 3 color maps, basically this is the Eiffel, the Midi-Eiffel thrust here, and this transverse fault here. You can easily recognize them both here in 2D and in 3D here. So these actually just do not only link the 3D model or the alien model we bring into the structural framework, but also become elements of the structural framework, the 3D extensions of the 2D views we see here. It's a very easy way to go about. Obviously, there are a few rules you need to respect, because each interpretation is a little bit different, because of a different author, because you're looking at a different level. But this is a very general approach that works in almost every situation you throw at it. That's the Liège Basin. Let's move from this one to another area in Belgium that we discussed in the groundwater session, which is at, well, the boundary between the Ruhr Valley Graben and the Campine Basin. And just for, you see that at this level, with the Ruhr Valley Graben, the number of faults that's being shown here is already quite abundant. And if you would zoom in, you would even see more. But you still can recognize, just because of the units that we indicate here, quite easily the boundaries between them. And actually, the fault, the boundary fault of the Ruhr Valley Graben here is the one that's going to be, that was in the groundwater session, one element of particular interest because of the how it blocked horizontal groundwater flow and resulted in vertical groundwater migration. Let's do again the same switch here. On top you see the 2D view, and below now we've brought in one of the 3D geological models, actually the ones that's being developed by one of the Flemish partner specifically for Flanders. And you see here all the layers are not, well, no, they should be too shallow, but you will not see any deformation of layers here other than through faults in fault blocks. Now, I nicely put them below each other. That's not enough. You always need to have some reference there. We only highlight one here, which is the Rauw fault, for those that remember these names from these sessions. But obviously you also see other structures that you could and you should actually bring in, at least as a geologist. As a more general stakeholder, you would only probably be interested in seeing those faults, the one actually here which matters for the discussion. And the what we're showing now is that what you see here, we had the 3D geological model in the groundwater session. They certainly have a 3D model, the people from SEK who presented their analysis, and I'm not going to repeat that. I'm just going to show the model here. But they did the whole discussion just on a 2D view of that model, and you can actually quite easily embed it here. And this default in their model, although it's a little bit offset, still corresponds very nicely to our our location of that same fault. So that is how you link these three, all of these different models. Here, actually, we linked already 2 different models to the structural framework, the groundwater model and a geological model. This, however, only tells you about one specific instance, in this case, a groundwater problem, a specific problem. When you talk about subsurface management, you want to go further. You want to bring in all these different activities in there. So let's try that very briefly with the groundwater model here on the right, and the natural gas storage here on the left, a very old 3D picture of that one. And I think I'm not following up on the Q&As anymore, but I saw that one of the first questions by Serge actually was how you're going to scale these different things one by one. Because if you look at them here, yeah, okay, is this going to influence this one? And to what degree and how big is that? These are indeed very important things to consider. So if we extend our structural framework a little bit, then you will again see the groundwater model in here. And these are, well, no faults there, but just the drillings that actually are used to produce and inject the natural gas into that dome structure, and also for monitoring purposes. If we put in the geological model as a 3D, just to give it some scale, it would sit there. And we know that we can link those model to the subsurface there. If we would bring in the natural gas model there, it would sit very tiny, postage stamp, very deep, actually much deeper than I can put it here on screen. This scale is only going to be a couple of 100 meters there. Here you're more like 2 kilometers depth already. So obviously, and this is also, it works and it's very important to do that. You also immediately see that what is lacking here. There is nothing here in the subsurface to link these 2 models. So this is a context that needs to be created if you want to go to an actual use of that. But I hope it gives you a sense, an idea of how you can actually bring elements together, even if they were created in very different contexts by very different people in very different projects. And so you don't, just in order to be able to discuss these things. And then moving to the last slides, this is how do you communicate? Because obviously if you bring people with a lot of knowledge into the room with people who have more generic interest, language is going to be a problem. I already emphasized that if it comes to limits, for example, we can do with 6 or 7 different words, of which most of them you already probably know and understand. But this doesn't exclude that you become much more complex, because basically there are 2 levels into the structural framework vocabulary to talk about and to name different things. So fault can be a limitless list almost of different kinds of fault types, as detailed as you want them to go. And again, to show how important we think cooperation is, we don't just design our own lists. We do it together with, for faults, Heike is certainly in the lead there because they are on topic there. But we work also together with other projects, and for other of these elements, we are actually the ones determining the vocabulary. Something that happens largely behind screens, but I think it's important to know that a little bit. Something else is that every element is also documented here. So if you would come across the Rauh fault, I'm just taking that example because it was one that we popped up here, and you wouldn't happen to know what it is, what kind of fault it is, and you're excused to do so if you're not really working on that area, then you will first of all understand how it actually fits into the bigger structures. That is not just a visual thing, it's actually inside the data system itself. And you can also just directly consult either definition of what is the raw fault, and then you will find it with reference to literature. And you can even ask it, what is a fault, if you suddenly happen to forget what that is. And even if these definitions are a little bit too technical, we tried not to make them too technical, but then even a geologist alien to our to the study area will be able with these definitions to give you a good background on what they are. So these are just a few of the more hidden things that I very quickly want to give you a glance at. And then to conclude, just going over different steps, because I hope they remained clear to the presentation. Yes, talking generically is very important. Linking a generic scheme into reality is very important. Also aligns perfectly with our methodology that we then use. You can basically translate generic one into an actual geological one and add it to the 2D structural framework that is already in place. And this will, by the way, by design, is an excellent and very brief introduction, speedy introduction into geology, exactly of the area that you need and how it relates to the more the wider zoomed out area. And this at the same time, it actually really is the framework for bringing in other results, other information, other models into the structural framework. And last but not leastly, it's also, we think a lot about how complex geology may seem just from a vocabulary point of view. So everything inside the system is, well, you can reduce the complexity there automatically. It's inside the system and everything is perfectly documented. Okay, I hope these were my few words on how to make the invisible part discussable. And I think it is time to move again to Renata to move to the Q&A round, I think.
All right, thank you, Chris. That was a very nice, way to wrap up our presentations, bringing the previous sessions together and putting them in this perspective of subsurface management. And please write your questions, comments to Chris. But I do see that we already have some questions there. So now I give the word to André.
Yes, thank you. So one of the question already Chris answered, addressed in his presentation. Maybe Saline, you have something to add to what already Chris commented about. This is the question from Serge van Hessel, which I'm going to read right now. In terms of communicating the risk of interaction conflicts, it is important to provide a good impression of scale. Explanatory figures often disregard the real scale of depth and horizontal distances. How can GeoConnect³ concepts help to improve the perception of scale in subsurface operations?
Yes, I think that Chris already answered on the technical point, and I just wanted to say that I totally agree on this comment that all the pictures we show for the moment in my own presentation is that we don't show the real scale of the depth of the different uses we are speaking about. And of course, if people are more aware of the deep that are concerned, they will maybe pose less question about risk and so on.
Yeah, and Andre, if I quickly may, I think it is a very relevant question, but one of the things I also have made clear, I think, in my presentation, and it is 3D, it's very often we saw it coming up through the previous sessions as, oh yes, just do 3D because that looks nice. It's also extremely complex. And I think by the visualization, you immediately saw that, yes, we can link 2D to 3D, but that doesn't automatically give you the information, give the user that information. So it's certainly still a point that we need to work on and really try out different parts there.
Yeah, I think there are some important lessons to learn also from mapping, when actually based on the interest of the stakeholder, you discard some other information. But this is I think this is going to be an effort of looking beyond the GeoConnect, where GeoConnect tries to establish the tool in itself. There's a really interesting question coming from Sarah Robinet. Not everybody understands English. Is it planned to translate in other languages?
Yeah, I think I will as being the senior one in the project will give that. Oh, it would be so nice to do this also in all of the different languages that we have. But however however impressive GeoConnect³ may look like, it is really a very poorly funded project with a lot of partners working very hard, but we have to make very tough choices. And one of the first choices we made was we will build everything only in English, but the whole system, and that's actually GP behind the GeoEra doing that, allows everything to be in multiple languages. So it is just a matter of putting in the effort, but we cannot generate that amount of work in the project and with the budget we have now, but it would be very nice to do so. And you're certainly very, I mean, among scientists, even among in Europe, it's English is a very common language, and we speak it all the time in meetings, and our technical vocabulary is based on English. But if we move out of that audience, yes, you need to be able to speak other languages as well. Absolutely. So consider this GeoConnect³ in that way as test case, but everything is in place to bring other languages in there.
Thank you very much, Chris, for the intervention. Since we speak about the accessibility, Antje Wittenberg, if those nice example pilots would be scaled up to a full pan-European coverage, what would be needed?
Okay, will I take that question? It is a very nice question, but it's a bit more tricky than that. I think I like the question because it goes back to the very origins of the project and to why we came up with the structural framework. The emphasis up until now has been very much on, oh, we'll do something cross-border, a cross-border geological model. That always looked very nice, but it has its limits because it stops basically when you cross into a different geological domain. Then suddenly your whole mapping methods and the method developed for generating that geological model of that area doesn't apply anymore because you run into a mountain chain or you cross a Veriscan front, elements like that. And that's why if we talk about Ruhr to Rhine, it's something we actually haven't stressed here, but we're very proud of that, is Ruhr to Rhine is not a geological entity. It is really, it's just bordered by two rivers, and it actually, it combines the most complex and divergent geological settings that you can actually get together on such a small country. And in that way, one geological model would almost be impossible, simply because geology is different, you need different mapping techniques, but also the amount of information is really very, very, very different. You've got parts where you've got 3D seismics, there are other parts where you have nothing. You just have to extrapolate into the subsurface because you only have the outcrops. These, in that way, I think for us, the way to actually cross those geological borders is to build a structural framework and then link to that in a more or less seamless way, as complete as possible, the different geological models in there. And scaling up pilots is always useful to the degree where you can do this. But we think that the structural framework itself is the cement or the reference geology to bring everything together. But yes, it's nice that you say that the pilots are there. We see it really as the framework for importing other elements, other data in there.
Yeah, there's also a question that caught a lot of attention. It's from Mev Boland. They are a very impressive visualization. Have you shown them to focus groups of targeted audiences, especially non-geologists, to see how they react to them if they are understanding what you're trying to illustrate? So I think that's a really nice question in this moment, which gives you also maybe a path for the future. organizing only for non-experts webinars or workshops.
Yeah, yeah, Isaline, if you want to drop in there, please go as well. But I certainly have something to say here, because this is obviously what we're trying to do, and we really like that question, or that you're on the thinking in the along the same path that we are, and we actually the first people we discussed everything with was with the experts. For example, we had brought together experts on the caledonites to see if the structural framework still makes scientifically sense to them. We just had two students working on 3-month internships because we asked them to do the geology of Belgium, or half of Belgium, bring it into the structural framework and try to explain it to others. For them, it was also a communication exercise and learning more about geology of Belgium. With the geotourism session, we also found that it was really very easy actually to do it there, to use it as framing there. So, and for the challenge we've taken up for next year is actually to use a structural framework to give a speed course, 2-hour speed course to 2 classes, 1 bachelor level and 1 master level of geology students, because the challenge is that we can explain geology of Belgium better in 2 hours than they can get in a whole course. And obviously from there, the limit is the whole story is open. We think we can basically use it very flexible for very different audiences. But yes, if you, it's certainly something we want to try out, and we do it step by step.
Thank you, Chris. So I think, Isaline, do you want something to add, or should we move to the...
I wanted to add that in the project, we are also working on the stakeholders of subsurface management, and we are trying to reach them and to have their feedback on our subject. And we are planning to organize hopefully a physical meeting, a physical stakeholders event in January this year, in the framework of the GeoConnect³ project, and also in the framework of another GeoEra project, which is the Muse project, dealing with geothermal activity in shallow subsurface. So they also have management, subsurface management issue, but other activities and other depths than in GeoConnect³. So we are complementary. And so with this event, we target very broad public, with not only geoscientists, but also industry, administrative, and hopefully representative of population and local stakeholders.
Thank you very much, Isaline. And I think you said it in the rehearsal just before starting the webinar, that we don't need to have only good questions, but also we need to have very good feedback. And I think the key to this project is actually, Chris and you spoke a lot about the case studies, geological case studies or the pilot studies, but I think another important thing it is bring us case studies from the outer world of the non-expert world to test the framework, the structural framework. In this way, we'll find out if it's applicable or not. So I think the key message that I want to send, and that I will shut up, it is please give us your feedback, and not necessarily only now, but in the future, and use all the social media and all the channels to communicate with us. Even with the poll that Renata is pushing me back to give a word to it. So thank you.
Thank you very much, Andre, Chris, and Isaline, for a nice discussion. I know we have questions left, but we don't want to keep you over our promised 1 hour and a half. So we will move on to the last part of our session, and it's going to be the polls. So I'm going to share them with you once again. So if you're ready to go, everything will be fine. If you weren't in the test questions before, you go to paulf.com/GeoEra900, and the link is in the chat for you. So I am going to go ahead and open our first question. So it's a statement, subsurface management is a pressing issue and we should be discussing it more. and then you can disagree to strongly disagree to strongly agree. And you know our opinion in GeoConnect³ for sure, but we're curious to see yours as well. And as we expected, it's agree, majority strongly agrees, which is our opinion as well.
Yeah, but this question, it's not just a question, it's also, I think, a message to outside. It's rare that we can actually ask this to a larger group of people, so that's why we are asking it here.
Absolutely, yeah. So it's that's easy. That's an easy one. Let's move forward. So you've seen from Chris' presentation the way GeoConnect³ is going about presenting geological information. So the statement is, this way is easy to understand. And again, you can go from strongly disagree to strongly agree. So no one disagrees for now. Majority agrees, which is very nice for us. That was pretty much consistent in all of the sessions. So that's a really nice feedback for us as well. And obviously this is all work in progress, and you know, we can definitely improve, but it's nice to know that we're going in the right direction. Okay, thank you very much for your answers. I'm gonna move forward to our next question or statement. It is easier to understand geological information about the subsurface. So for example, cross-sections, 3D models, once these are contextualized in the structural framework, sorry. So again, referring back to Chris's presentation, where he was trying to embed the different 3D models, cross-sections in the structural framework. Again, majority agrees, which is nice for us. And certainly, at least for me, I'm one of the people that struggles with 3D models because they might look very nice, but I really struggle to get my head around scales and how this looks, you know, compared to our 2D knowledge. So that's nice. Thank you for your answers. And I move forward to the next one. And this is a free text, and you can upvote the entries. But what are the pros and cons of the GeoConnect³ way of presenting information? And please indicate if you're talking about a pro or a con. And while we give you a minute to give us some input, I would ask Chris and Isaline and Andre, I would ask the three of you if anyone wants to make a quick final comment on given all of the presentations that we had, and how do you think this applies? I see Chris wants to.
No, I want to actually hear the opinion of Andre, because he's the one. It's now the fourth session, and we haven't actually asked him this kind of questions. So I think it's his turn now.
Yes, thank you. Well, my opinion, I mean, I already shared with you. I think it has a lot of potential. And then working a lot with knowledge management tools for the European Commission. So being a geoscientist working among policymakers, definitely I can see the potential of making the language of geology more understandable with the structural framework that you're developing. But also I can see a lot of connections with the commercial tools. For example, I just mentioned to Renata today, GeoFacets, which is a really, it is a commercial tool. It is expensive. You have to buy it, but they go in the same direction. So I can see here two really important messages based on my own experience. That is an idea that definitely it's interesting to explore, and it's definitely going to work in the future. So that's my opinion. Looking into it, but of course we need to concentrate our efforts and then see what we actually can fix with this one, because if we propose too many targets, then it might be, as you said, too much for the project.
Nice, thank you very much, Andre. It's only fair that on the last one you get to answer some questions as well and not only asking them.
So I would like also to add maybe that I have an image in my head that I see the subsurface like an upside down city. And then we are heading towards the urbanization right now. So we have to really take care, how do we use the subsurface in the future? So that's the challenge that we have to take on board.
Oh yeah, that's a very nice analogy, the upside down city. So I see we have quite a few comments there. We have a reaches wider audience virtual, which is both a pro and a con actually, because it does depend a lot on technology. So that's a really interesting comment there. And another pro, it makes you think about the limits of geological units as controls on their history, properties, potential uses, which is, yeah, it's very nice to see this comment because it's exactly what we're trying to do. So we see easy to understand, three-dimensional GIS has to be used systematically to present information. Yeah, we have a con, challenging to implement all kinds of geoinformation. That is definitely true. And we need to understand geology vocabulary in English to be familiar with maps and the representation of the geology, which is also a con. But as Chris said, the whole setup of GeoEra is perfect for following up. And we hope that by, let's say, giving this baseline, that we can introduce different languages and other aspects that refine the definitions, make them as easy as possible. So thank you very much for your answers. We can move ahead to the next question. And this is a true feedback time. Which subsurface uses would you like to see integrated into our case studies? So this refers back to Isaline's presentation, where she presented a few of the case studies that we are already looking into. But it would be nice for us to get to know from you which are the things that you think are important. And if anyone, Chris, Andre, Isaline, wants to make a quick comment on that while we wait for our first answers. No one?
Well, I can make a quick comment first, but I'm not going to dictate a list there. But we are open to receive anything, so it doesn't even need to be. I know Isaline has focused a lot on geoenergy, and GeoConnect³ also sits into the geoenergy team. But we've done GeoEra as a whole does raw materials, does groundwater, so it's much wider than that. So do not feel forced to stick to just geoenergy ones. For example, we've got in some of the sessions we showed results from Minerals for You. We've explicitly had a groundwater session, although that's just because some GeoEra projects are on there. In the first session, well, it's not maybe it could be an application as well, although for us it was more about communication. But the geotourism, for example, actually we're much closer to that when we thought we would be. Preparing those presentations were actually fun for us because we had quite a bit of information lying around. So yeah, we'll just, I leave, obviously I do not want to answer the question for the others, but these are my general ideas about it.
Thank you, Chris. And I see we have already some nice input. So we're going to start with all waste management, water, energy. You may need to build the ability to add in biological aspects of the subsurface too, which would be quite a nice follow-up as well. Energy storage is mentioned a lot. Nuclear waste storage, deep geothermal, which is definitely something we're looking into. CO2 storage as well. Geotechnical parameters is an interesting one. Wind farms, because they may be sealing off important geological resources. And yeah, I like this comment that it is important to communicate about examples close to people. So in Belgium, different kind of groundwater exploitations and geothermy. So I think we have some very nice comments there. Thank you very much. So I'm gonna move on to our next question. What did you like most about this session? and we're reaching the end of our poll. But as I said, there will be a similar event. We don't know if online or presential yet, but organized for the Pannonian Basin area. So for us, it's important to know what worked, what didn't work. This question is a bit biased on the positive side, but if you can give us some feedback on what were the positive aspects of this session. And as well, I think that you already have the email of GeoConnected project, geoconnected@geoera.eu. And we are really interested to hear your feedback, as everyone else stressed already today and in the other sessions. Please don't hesitate to drop us an email. We will be very, very happy to hear feedback about these sessions or about what you've seen. If you have more comments, more ideas, we're really collecting those. We're really at that stage to collect all of those and direct the rest of our project the best possible. So we have a few comments coming in. So easily accessible, good topic, highlighting the importance of 3D models. That's right. Learning about 2D and 3D depictions of geology. You're showing that it can be done or how it can be done. Visualization is nice. 3D models of neighboring areas put into context. Yeah, that's very interesting to put them to scale. And I think this is a really crucial thing. Okay, so thank you very much. I know that we are already at 11, so we're gonna move forward to the very last question. How would you rate the event today? And okay, average, excellent, good. Most people in the good, so we're happy with that. Luckily, no technical problems today, so we're very happy with that for sure. So thank you very much for your input, and I do not want to keep you much more. So I just want to maybe try to wrap up this webinar series. And I hope that during these events, we were able to demonstrate how our methodology works and how these preliminary results already help to provide context for different things, such as different types of geomanifestations, which can often be sites of interest for geotourism and geoheritage. New information being generated, such as groundwater models or geothermal resource information, as well as many other topics that we didn't specifically address, but that we're looking into. And with your feedback, we will have more ideas from now. And by using these data, we can understand the composition and structure of the subsurface and the processes happening in it, even if we're only looking at the surface, as is the case for geomanifestation data, for example, most of the time. So this way, we can shed some light into the complex issue of subsurface management. And we also hope that you agree that these efforts are going in the right direction to make geological knowledge more accessible and building the bridge to show how our science can serve society. So if you want to know what's next for our project, we have our website and in the GeoEra, our page in the GeoEra website, and we are all over social media. So the links are there in the chat for you, and you can find us pretty much everywhere. We also have a YouTube channel now where this session will be available because it's been recorded. And this is it from us. Thank you very much for joining us today. And if you joined the previous days, thank you so much for coming back. And I just want to also thank one last time our panel of today for the very nice talks and the very interesting discussion.
Okay, no, you are welcome, Renate. Okay, bye to everyone.
Bye to everyone.
Bye.
Thank you.